All right, everyone, good day. Hope today's finding you well. Hope you're ready for a little bit of a review today. Today's mainly just a review of something you've gone over before, so hopefully it makes sense. A while ago, we learned about equations, one-step equations, and how to solve them. We spent about a week doing one-step equations, how to get a variable all by itself. I'll speak some more to that in just a second. Today, we're going to squish it all in one, squish all the operations into one. But today we're doing one-step equations, just a whole bunch of them. So take a look. Let's say you've got an equation that looks something like this. X plus 5 equals 81. And the idea, the purpose of this is to try to figure out what that variable is. Now, ones like this you can probably do in your head. But we're trying to teach you the process. So maybe if I make a more complicated one, y plus 89 equals 64. Maybe that one will give us a little more to think about, just so you can't just do it in your head and think, oh, I know how to do this. Eventually, you'll be doing 10-step equations. So just trying to teach you the process. And it's more important that you learn the process than for today being able to figure out the numbers that are associated with each variable. So when you have a problem like this, you've got an equation, you've got a variable, and some numbers and operations associated with it. See which one of these phrases makes the most sense, or what you remember from before. We basically want to undo the operation. Another way to, operation. I'm going to say this, in 4 different ways. And just attach your brain to the way that makes the most sense to you. We're wanting to isolate the variable, or get the variable all by itself in the equation. To do that, we use the inverse. So it's the inverse of 5 to try to get rid of that 5. Another way today we talk about maybe canceling out the number. It's kind of not really a good mathematical way to say it, but you might have heard that in the past, and I'm fine using it to help you understand. We're just trying to get the variable to go to 0 or to 1. And then finally, you might hear say, we're going to move the variable, or not move the variable, move the number to the other side of the equal sign. So to move the number to the other side of the equal sign, across the equal sign. And here's where we move that. We want to get rid of this 5. We want that x to be all on its own. When we're all done, we want to have an equation that just easily reads x equals something. And the way to do that is to undo the operation. This plus 5, we make it a minus 5. It's the same thing as isolating the variable. We're canceling out this 5. It's going to go to 0. But we're moving that 5 to the other side of the equal sign, but we're doing that by subtracting 5 from both sides of an equal sign. You have to do it from both sides. That goes to 0. X equals 76. It's the exact same thing in this next one. To get y all by itself, this plus 89, we do the opposite operation. To undo something, we do the opposite. So we minus 89 off of both sides of the equal sign. Because that means this goes to 0 and y is all by itself. And then equals whatever your calculator says, 64 minus 89 is. And 64 minus 89, negative 25. To do this step, to get these variables all by themselves, we're just undoing whatever's on the variable. Let's say I've got 17g. What if I have the 170g is 153? Well, how do I find out what g is? Well, I do the opposite operation. Undo the operation. I do the opposite operation. We undo by doing the opposite operation. And it's an equal sign, so we have to do it on both sides. So times 17, so we do divided by 17 on both sides of the equal sign. They're both equal, we have to do it to both sides. G becomes whatever 153 divided by 17 is. 9. So G is 9. And if you put 9 back in there, 17 times 9, you'd get 153. It works with add, subtract, multiply, divide. M minus 3 is 2. So what is M? Well, you just do the opposite. You add 3 to both sides. M is 5. It works if I've got K divided by 6 equals 12. So what is this number that I divide by 6 to get 12? Please don't say 2. If you're saying 2 divided by 6, that's 1/3. You're trying to do it fast instead of just undoing the operation. It's divided by 6. So we multiply both sides by 6. These cancel out. They both become 1. 6 divided by 6 is 1. So K is 72. Add, subtract, multiply, divide. It works with easy numbers, hard numbers, simple numbers, complicated numbers. For example, it's this one. 20 m's is 260, if you can see that. 20 m's are 260. So how do we get the m alone? Well, the 20 is multiplied on, so we divide off the 20 from both sides. That goes to 1, so m is, on your calculator, you'll find that m is 14. Or 20 times 14 is 260. Right here, what number on that one makes 0? Well, it's divided by 11, so we times both sides by 11. Those go away, so n equals 0 times 11 is 0. And that makes sense because 0 divided by 11 is 0. Right here, let's do this one, minus a subtraction one. So we add 1 to both sides. Those go to 0, so n is all by itself equals your calculator. If you type that in, you get negative 12.75. You start at negative 13 and you come up when you're now negative. With decimals, if you've got a number multiplied onto x, you divide by 9.61, divide by 9.61. I have no idea what that's going to be. None at all. 77.841 divided by 9.61 is 8.1, it looks like. So x over here, that's just 1, it's all gone, so x equals 8.1. So in all of these problems, all of these types of situations with one-step equation, you are undoing the operation. You are isolating the variable. You're doing the opposite operation. You're moving the number to the other side of the equal sign. Those are 4 different ways to say it. If this has been hard to follow, by all means, go to Google and just type in one-step equations and see if there's another way you can hear it that can make more sense than what I've said. Thanks for watching. Have a wonderful day.